This presentation is about area under curves. Lesson objectives: to understand the link between definite integration and area. To be able to find area under curves. Now, one way to approximate the area under a curve of y equals f of x between x equals a and x equals b is to basically form a series of rectangles from left to right as so. So basically we make the height the same as the y coordinate and we try and have a fixed width which we call delta x. So fixed width, which we call delta x. So I have each width equaling delta x. And we go from left to right, so we go all the way up to the curve and go across delta x. All the way up to the curve, across delta x. All the way up to the curve, across delta x. All the way up to the curve, across delta x. This is an approximation to the area of that curve. First three rectangles underestimate, the last two rectangles overestimate. Now, that would make the area equal to the sum of the area of the rectangle, so the sum of the y coordinates times delta x, the width of the rectangle. Now y is equal to f of x, so it's delta times f of x. It's a sigma of f of x times delta x. Now, this approximation will become more accurate as delta x gets closer and closer to 0, because the rectangles will be thinner and we'll have more uses of the y coordinates to work out the area. Now it turns out as delta x tends towards 0, the area of the curve becomes between the integral between a and b of f of x dx. So the sum, when as delta x tends to 0, is equal to the integral between a and b of f of x dx. So we can use the integral to find the exact area of the curve. In this case, we want to find the shaded area in the diagram of, so the area under y equals x to the power 4 between x equals 1 and x equals 4. So we need to identify the correct integral. In this case, the correct integral is the integral between 1 and 4 of x to the 4 dx. Integrating, increase the power by 1, divide by the new power. So increase the power by 1, 4 plus 1 is 5, divide by the new power, divide by 5. So x to the 5 over 5 between 4 and 1. So definite integration, we stick the 4 in first, take away, sticking the 1 in. So we get 4 to the power 5 over 5 minus 1 to the power 5 over 5. Sticking that into a calculator, this is equal to 204.6. Second example. Find the area bounded by y equals 4 minus x times x plus 2 on the positive x and y axes. So to make sure we get the right integral, we'll need a sketch of the curve. Now that's a factorised quadratic, so 4 minus x would give us that it crosses the x-axis at 4, because 4 minus 4 is 0, and x plus 2 will give us that it crosses the x-axis at minus 2, because minus 2 plus 2 equals 0. So marking those points, the curve crosses at minus 2 and 4 on the x-axis. Now if we multiplied this quadratic out, we would get minus x squared, so it's in an n-shaped quadratic. Now the area needs to be bounded by this curve and the positive x and y axes. So it is the grey shaded area in the top right quadrant. So the integral will be between x equals 0, the y-axis, and 4 of 4 minus x times x plus 2 dx. Now, to be able to integrate this function, we'll need to multiply out that quadratic expression. So it's the integral between 0 and 4 of 4x, 4 times x, plus 8, 4 times 2, minus x squared, minus x times x, minus 2x, minus x times 2 dx. So the integral between 0 and 4 of minus x squared plus 2x, as 4x take away 2x is 2x, plus 8 dx. And now we're in a form where we can integrate. So integrating term by term, minus x squared, increase 1 to the power, we get x cubed, divide by new power, divide by 3, 2x, increase power by 1, 2x squared, divide by new power, divide by 2, and plus 8, a constant, integrates to plus 8x. 2 divided by 2 is 1, so the middle expression simplifies to x squared. So we end up with the integral being minus x cubed over 3 plus x squared plus 8x, taken between 4 and 0. So to take the integral between 4 and 0, first of all we stick 4 in for x, minus what we get when we stick 0 in for x. So we get minus 4 cubed over 3, plus 4 squared, plus 8 times 4, minus 0 cubed over 3, plus 0 squared, plus 8 times 0. Calculating, we get 80 over 3 as an exact answer. This concludes the presentation.